A substellar object, sometimes called a substar, is an astronomical object whose mass is smaller than the smallest mass at which hydrogen fusion can be sustained. This definition includes brown dwarfs, a form of stars similar to EF Eridani B, and can also include objects of planetary mass, regardless of the formation mechanism and whether or not they are associated with a primary star. Assuming that a substellar object has a composition similar to the Sun's and at least the massive Jupiter, its radius will be comparable to that of Jupiter. This is because the center of such a substellar object just below the hydrogen burning limit is quite degenerate, with a density of approximately equals 103 grams per cc. But this degeneracy lessens with decreasing mass until, at the massive Jupiter, a substellar object has a central density less than 10 grams per cc. The density decrease balances the mass decrease, keeping the radius approximately constant. A substellar object with mass just below the hydrogen fusing limit may ignite hydrogen fusion temporarily at its center, but although this will provide some energy, it will not be enough to overcome the object's ongoing gravitational contraction. Likewise, although an object with mass above approximately 0.013 solar masses will be able to fuse deuterium for a time, this source of energy will be exhausted in approximately 106 to 108 years. Apart from these sources, the radiation of an isolated substellar object comes only from the release of its gravitational potential energy, which causes it to gradually cool and shrink. A substellar object in orbit about a star will shrink more slowly as it is kept warm by the star, evolving towards an equilibrium state where it emits as much energy as it receives from the star. Classification. William Duncan Macmillan proposed the classification of substellar objects into three categories based on their density and phase state: solid, transitional, and dark gaseous. Solid objects include Earth, smaller terrestrial planets and moons, with Uranus and Neptune as transitional objects between solid and gaseous. Saturn, Jupiter and large gas giant planets are in a fully gaseous state.